I'm going to be showing you how the extremely complex and sophisticated 7-speed sequential transmission gearbox works in the brand new LEGO Technic McLaren P1 42172. Before we even start looking at the mechanisms, allow me to just give you a basic demonstration. I have hooked up a powered up large motor to one of the rear wheels, and I'm using the Mindstorm's hub to turn the motor at full power. Here we have the 7th speed, in which the engine turns extremely slowly in comparison to the wheels. Now we have the 6th speed, 5th, 4th, 3rd, 2nd, 1st, neutral, and back to the 7th. Notice that this is actually a real 8-speed transmission, unlike the Lamborghini or Daytona Beach, which had just a basic 4-speed transmission with a multiplier to achieve the 8 speeds. However, in the transmission of the McLaren P1, there is a neutral gear, where the first gear normally would have been in an 8-speed transmission. Don't worry if you don't understand everything quite yet, because I will explain everything right now. So first of all, let's look at the selector here, which would normally be drive, neutral, and reverse. But it's not your basic multi-directional gearbox here like in the Lamborghini or Daytona Beach. Instead, the main selector is actually linked to another changeover catch. Essentially, think of the car as having two sources of power. First, we obviously have the fake V8 piston engine, and we also have the fake electric motor. In the neutral position of the selector, if you turn the rear wheels, the driving rings will spin, but nothing will happen. If you put it into the rear position, the wheels engage into the fake electric motor, but not the gearbox itself. The front driving ring is not a factor because it does not engage into anything. Here is the exact travel path of the motion, and essentially we just have some 16-tooth gears at the start until eventually the motion goes from a 20 to a 12, then 20 over 12 once again, and then 14 over 22, which is just the ratio of the differential gears. To get our final result, we simply have to multiply all of the ratios together, which gives us a final ratio of approximately 1.77. Once the motion fully exits the engine, it will have to travel the exact same path, so let's just call this ratio our coefficient. I guess you reverse using only the electric motor, and in the front position, we engage into both the fake electric motor as well as the V8 engine. Now, both the front and rear driving rings are engaged. Even the basic front selector is quite complex. And now, let's look at the paddle shifters. Essentially, this mechanism uses that newer 8-tooth ratchet gear that was introduced in the Yamaha motorcycle, which allows the paddle shifting to turn the speed switching axle at 45-degree intervals rather than 90-degree ones like what we saw in the previous cars. Remember that there are 4 90-degree positions in a full rotation, but 8 whole 45-degree positions in this brand new mechanism, which allows for actually having 8 distinct positions in the gearbox rather than relying on a multiplier like in the previous cars. If you're already fascinated by these insanely complex mechanisms and you would like to get my full review of this car as well as a detailed explanation of the Mercedes' gearbox, then make sure to subscribe and turn on notifications. No pressure though. No pressure. Now, let's look at the main gearbox itself. First, to make things simple, you must understand that any gearbox, no matter how complex, has only one input axle and one output axle. I've highlighted both of these axles on the gearbox, and this will help you determine the exact travel path of each speed. There are 4 driving rings here, and let's start with the neutral. If we begin from the input axle, we will see that the motion does not go anywhere, because not a single driving ring is engaged in this position. For the first speed, one of the driving rings at the bottom engages, and the motion first passes from a 16 to 20, then back to a 16, so this doesn't change anything. Now comes the interesting part. We go from a 16-tooth gear into a blue 20-tooth gear, and then again from a 16 to 20-tooth gear. Now the motion will travel from this 12th-tooth gear into this 24-tooth gear, and then the motion exits from the main gearbox. But before it goes into the central selector, it has to travel from a 20-tooth gear to a 16. Now we'll multiply everything, and remember, we also have to multiply by that approximate coefficient of 1.77, so we get our final result of 0.71. Let's go to the second speed. Here, the travel path is much easier to see. We go from a 20 to 16 and back to a 20, which is just 1 over 1, then from a 12 to 24, and then we just go through the exit, which is 20 over 16, and then by our coefficient, which is 1.77, so our final resulting gear ratio is approximately 1.1. For the third gear, we go from a 24 to a 12-tooth gear, and then from a 16 to 20, and from a 12 to 24, canceling that out. Before coming to the exit, the resulting ratio is 1.77. Now for the 4th gear, we engage into the brand new 12-tooth gear with clutch, but it cancels out here, and the ratio of the gearbox itself is just 20/16, which gives us a final result of 2.76. For the 5th gear, we have to look at the bottom again, and we travel from a 16 to 20, and then from 24 to 12, from a 20 to 16 tooth gear once again, so those cancel out. We just have to multiply 24/12 by the exit and the coefficient, which gives us a result of 4.42. The 6th speed takes us through 20/16, then from a 24/12 and 20/16 again, so let's see the final result, which is 6.9. The final 7th speed takes us from a 24/12, then from a 24/12 again, and then 20/16 in the gearbox itself. This gives us a final resulting ratio of a whopping 11.05. This explains why the engine is so incredibly slow in the 7th speed relative to the same exact speed of the wheels. I've created a table for you to easily be able to see which speed has which gear ratio. Notice how the difference in all the gear ratios does not appear to be linear, but rather exponential. Wow! I only just noticed this as I was writing this script, and we haven't even scratched the surface of how the torque changes in the gearbox. I mean, this is insane. But anyway, if you're struggling to build this gearbox and you have run into problems, or you just have any additional questions about how this gearbox works, then please just ask in the comments. I read every single comment, and I will also respond to every single comment, especially on this video. Also, does the real version of this car change speeds exponentially like this one? Then please let me know in the comments below. This is your unbrick here, and I'll see you for my full review of this car.